Find the transition matrix from B1, 3x, comma x squared minus 1 to B prime, 5 minus x, comma 1 plus x squared, comma 7 for the bases B and B prime of P2, where P2 stands for all polynomials of degree 2 or less. All right, so essentially what we're being asked to do is to write the basis vectors in B in terms of basis vectors of B prime, okay? So we set up basically a system of equations. So I'd have one equation, C1 times 5 minus x plus C2 times 1 plus x squared plus 7C3 equal to 1. So that's all this stuff right here. And then D1, 5 minus x plus D2, 1 times 1 plus x squared plus 7 times D3 equals 3x. That's the next vector. And then finally E1 times 5 minus x plus E2 times 1 plus x squared plus 7 times E3 equals x squared minus 1. So what I'm looking for is basically these constants here, C1, C2, C3, all the D's and all the E's, okay? Now, how would I go about finding that? Well, the best thing to do, in my opinion, is to simplify your equations a bit. So one thing we can do here, that's in red, is to distribute the C1, the C2, and simplify that a bit. What I mean by that, by looking at what we have down here, is as follows. I would collect the combined like terms, rewriting that by combining like terms. So all the constants together, all the x's together, quote unquote, and all the x squareds together, and all the constants together would be 5c1 plus c2 and then plus 7c3. That would make a constant. And for the coefficient of x, that would be minus c1. And then for the coefficient of x squared, it's a c2. Okay? And then I would set it equal to 1, but 1 as a polynomial in P2, that would be 1 plus 0x plus 0x squared. And I would do the same thing for the next equation involving the d's, and you would have 0 plus 3x plus 0x squared, writing 3x as a polynomial in P2. And last but not least, the same thing for x squared minus 1. I wrote that as minus 1 plus 0x plus x squared. Okay, so I want to follow that same order that I did with all the polynomials, meaning the constant first, then the coefficient of x, and then the x squared. All right, and from there we technically set up a system of equations. The reason for that is if you look at a polynomial, two polynomials, and you set them equal to each other, then the coefficients must equal each other. So the constant coefficient on one polynomial must equal the constant coefficient on another polynomial. The coefficient of x must equal the coefficient of x, and then the coefficient of x squared must equal the coefficient of x squared on the other polynomial. So I'd have to have that 5c1 plus c2 plus 7c3 would equal 1, minus c1 would equal 0, and then c2 would equal 0. Okay, so writing that out is what you get here. Okay, and then likewise you would get the same thing for the d's, and the same thing for more careful there, not the same thing, but the system that you have on the left hand side would be the same for all of them. Okay, so the only thing that would change is what we have on the right hand side here with the vectors. Okay, now and from there I'd have to solve these three systems of equations. Now I could do this separately for each, not a problem. However, and for the sake of saving time, what we could do is as follows. We can set up a matrix where one side would be the coefficient matrix, which is like the same for all of these, which is 5 1 7 minus 1 0 0 0 1 0, reading that as a row. And then what I'm going to do is I'm going to set this equal to all the vectors that I have on this side, are like all the answers here. Okay, and what I'm going to do is I'm going to do elementary row operations, just to get this down to reduced row echelon form. And yeah, solve for all the C's, the D's, and the E's here, okay? So this is a shortcut. And you might have done something like this when you were asked to find the inverse of a matrix. So in that sense, the computation is similar, okay? So if you row reduce this, okay, and I'll let you do all the work for that, you get as follows. And if you were to go ahead and interpret this right here, this would imply that C1 equals 0, C2 equals 0, and then C3 equals 1/7. D1 equals -3, D2 is 0, and then D3 is 15/7, and etc. Okay, for the rest. So that's how that would work out for what these represent. And that is what you see on the right-hand side of this matrix. That part put together with, that part, we can call it a matrix, and that's your transition matrix, okay? So that's how you go about getting a transmission matrix for bases, for, in this case, P2 for a polynomial. Okay, so I'm gonna make another video for how to use these transition matrices, the application of them, and I'll link that to the worksheet that you got this link from. Okay, thank you.